seems here that oxygen has made friends with iron. It's unfortunate, however, that they won't be able to play on that seesaw for long, since oxygen causes most metals to rust. I think someone should get the nurse.
Sodium and chlorine form salt, or have you heard? When they get together, electrons are transferred. Ions are produced, and opposites attract. Ionic bonds are formed, and
this
that's
is episode
a
602
fact.
of Unit 5, and we are going to name chemical formulas that are ionic. We've already covered covalent and did really well on that. So let's look at how to do ionic formulas. You're going to need to get a couple of things. You're going to need to get this common ions chart. This is in your binder in the information section. And if I will try to remember tomorrow to ask you to make sure you have one of these. If you don't have one, you can always just look at it on here until the next day and get it in class. The other thing you're going to need to look at is your naming flowchart. And we are going to be going this direction. When we did molecular compounds, we went this direction and we named them using the prefixes if they were nonmetal and nonmetal. And now we're going to look at metal versus metal and nonmetal together and how we name those. So the first thing we need to do is talk about what an ionic formula is and how we write it. So what we do is we write the symbol for the elements, and the metal is written first. The nonmetal is written second. And then we determine the charge on each ion. And we select the ratio. Oops, not ration, the ratio. That will make the total positives equal the charge of the total negative charge. So we've got to go back and look at those charges that we have on the periodic table. And if we look at the examples that we have at the bottom of your notes, the first one is sodium chloride. So the first thing we want to do is we are going to write the metal first. So the metal is Na, the nonmetal is Cl, and it's going to be named like that. It's going to be named the metal and the nonmetal. All right, then we need to determine the charge on each ion. So if you look at your periodic table, or you can go back and look at this, if you find sodium, sodium is a +1. Chlorine over here is a -1. So we would do positive here, +1, -1. Now the ratio that will make the total positive and the total negatives equal each other. Well, because these charges are the same, they equal each other. So we only need one of each. We need NaCl. Since we have one of each, we write sodium and chlorine together. We do not put the charges in the formula. So this is the formula. This is just helping us figure out the formula. And if we look at the next one, we have magnesium chloride. So magnesium would be Mg. Chlorine would be Cl. If we go back and look at our chart, Mg is right here. It's a +2. Cl is still a -1. So we're going to do +2, -1. Now the ratio that will give us the same charge on this, this is a +2, so we need to get a -2 charge to balance it out. And the only way to do that is to have two of these. So that gives us MgCl2 as our formula. Now, there's a little trick to doing this for ionic compounds, and that is called the crisscross method. So if you look at the bottom of your note sheet, and it has the crisscross method there. So the crisscross method, first you write the symbol of the cation, which is the metal, followed by the symbol of the anion, along with their respective charges. Okay, then what we're going to do is we are going to use the absolute value that means take the charge, the number, or the positive or negative off of it. We're going to take the absolute value of the charge of each ion as the subscript for the other one. If a subscript is 1, omit it. If the subscripts are the same, omit them. Okay, so you don't put 1s in any formula. And we talked about that when we did the covalent ones. So if you look at this example down here at the bottom, we have calcium and we have chlorine. Calcium's a positive 2. That's a negative 1. So you cross them and bring them down. Cross them and bring them down. That would be a 2 over here, a 1 down here. We are not going to write the 1. It's understood. So it'd be CaCl2. That would be called calcium chloride. If we look at lithium, we'll do the same thing. Positive 1, negative 2. Cross them, bring them down, get rid of the 1. So that's the crisscross method. It makes it very, very simple for naming your ionic compounds. Now, if we look at, there's 2 different types of ionic compounds that we need to look at. And the first thing we'll do is we'll go back and look at our flow chart here. We're on ionic. So binary is 2 elements. We're going to talk about binary first on how to name them. And then we have something called ternary, which is 3 or more elements, and the way we name those. First of all, binary consists of only 2 elements. Okay, you name the metal ion, which is the cation, and then you name the nonmetal, which is the anion. And we do the same thing that we did in the covalent compound. We change the ending of the last one to IDE. So fluoride, nitride, oxide, hydride, that kind of thing. Okay, when metals that can form more than one type of ion are in a compound, we use a Roman numeral. In parentheses after the name of the metal to show the charge. So let's look at some examples of how to do that. If we have NaCl and we have MgO, so let's look at the first one. These are binary because we have 2 elements, Na and Cl, Mg and O. NaCl right here. We're going to take the first one and name it. So the first one is just sodium. Then the second one, we're going to name the nonmetal and put an IDE on the end of it. So this would be chloride. And then for the next one, we have magnesium and we have oxygen. So we're going to look at magnesium. Then that would be oxide. Now, how do we know we didn't need to use the Roman numeral? Well, you can look at this chart. And on this chart, you have something called type 2 cations, and these are the ones that have more than one charge, and the Roman numerals are beside them. These are the common ones. Basically, what you look at is anything on the periodic table that's a transition element, that's in the middle of the periodic table. It has a possibility of having more than one charge. So you have to look at that. The ones that have always have the same charge are up here. Those are the monatomic ones. So you can always look at these, the monatomics. But your polyvalent ones are going to be sitting right here. There's a couple more. Let's say Cu. Let's erase this. And look at Cu2S. All right, now Cu is copper. So if I write down copper, and I know that S is sulfur, so I'm going to write down sulfide. But when I look on my chart, copper is right here, and it can be either a +2 or a +1 charge. So how do I figure that out? Well, what I need to look at is think about the crisscross, bring them down, and do that backwards. So if I look at sulfur, sulfur is a -2. So I crossed that and brought that down. Right here, crossed that and brought it down. And right here, I don't have anything, which means that would be a 1. So that means up here, that had to be a 1. And it's positive because it's metal. So in parentheses right here, I'm going to put a Roman numeral 1. So that's really the only thing that's kind of tricky about this. The other one that you're given is SnCl4. So we know that Sn is 10. We're going to put 10, leave a little space, and then that would be chloride. Notice we are not using prefixes for any of these. We don't use the prefixes at all on the ionics. If I look up, I'm going to go look up 10 over here, and I'm going to see that 10 has a Roman numeral 4 and a Roman numeral 2. So those are the two most common ions for 10. So I'll go back over here. And I need to go ahead and write down up here, chlorine is a -1. It's always a -1. How do I get that? I look on my periodic table, or I look at my ion chart. So if I crossed this, this would be a 1. Well, this is a 4, so this would need to go up here, which is a +4. So this is 10,4, which is 10,4, good buddy, 10,4. Okay, and that's how you name binary ionic compounds. Now let's look at the rules that are on your flowchart so that if you get stuck, you can always go back and look at these rules. So we are looking right here. All right, binary 2 elements contains only monatomic ions. You find on the periodic table, you name the first one, its regular name, but the anion, you drop the last part of it and you change the end of it to IDE. All right, so that's what we did on all of those. We wrote the first element. We didn't put ion in there. We didn't put copper ion or sulfur ion. We put copper sulfide. We changed the ending to IDE. Those are only if we're talking about binary compounds. So now let's talk about ternary compounds. And ternary compounds are a little bit more complicated only because they have more than 2 elements in them. So this is made up of 3 or more elements. And what we do is we name the metal first, then we name the polyatomic ion. But we do not change the ending to IDE. So your polyatomic ions that are on your list, this is the same list right here. I just cut it apart, this polyatomic. Your polyatomic ions, the names of them are right here. So all you do is name the first element and then you name the polyatomic. So these are a little bit simpler, and that part of it makes it a little bit more complicated if you have a Roman numeral to try to figure out what's going on. So let's look at some examples. If we have, see, Na2SO4, Na2SO4. First thing I'm going to do is write down, I know this is sodium, but does sodium always have the same charge? So I'm going to go over here to my list and I'm going to find sodium, and sodium is right here in the monatomics, which means it always has the same charge, no Roman numeral. So sodium, And then I have to look up SO4. SO4 has to be over here somewhere. There it is, right there. SO4 is sulfate, so I just write sodium sulfate. That's it. And then the next one is FeCrO4. So here's my metal. That's iron. And CrO4 is down here. That's chromate. Now, because I know that iron is a polyvalent element, it's a type 2 cation. It's going to be right here. It has a +3 or a +2, so I need to figure out which one it is. And in order to do that, I need to know the charge of my chromate. Chromate is a -2. So I'm going to go back over here, and I'm going to put, right here, I'm going to put -2. Now, this whole thing is a -2 charge. So if I crossed it and brought it down, I crossed this one and brought it down, that would be a 2. So what has to be here? Well, in order for me to have no numbers down here, I don't have anything, it's a 1-to-1 ratio. That means this has to be a 2 also. So they cancel each other out. So that means this has to be a +2. +2, -2 cancel each other out because the formula I was given was this. There are no numbers. That 4 goes with chromate. There's only one chromate and one iron. So I know that iron is Roman numeral 2. Those are parentheses. Okay. Now, let me see if I can think of another one that we can do just real quick. Let's try PbC2O4, and now we have 2 of these polyatomic ions. So I have 1 lead, and I have 2 oxalates. And I know that's called oxalate because I find it right down here at the bottom. There's oxalate right there. So I'm going to go ahead and write, this is lead oxalate. Now, I have to figure out what the charge is on this lead because I know over here, if I look at lead, lead's right down here, and it can be a +4 or a +2. Now, I know that this is a -2. So if I were to follow my rule and bring this down, that would be a 2. So this, I have to have 2 more, I have to have double this that I have of this one. So that means I really would have 4 here, which means Pb would be a +4. Now, how do I know that? Because this was a 1-to-2 ratio, a Roman numeral 4 right here. Now, one thing that's different for ionic compounds is they have to be in lowest terms. And that's why I didn't leave a 2 and a 4 here. I made this 1-to-2. Ionic compounds always need to be in lowest ratio. And you need to, and it's on your notes at the very, oh, I put it again, lowest ratio. So they need to be in the smallest ratio, the lowest ratio. So we're talking like a 1-to-2 or a 3-to-4. You cannot have a 6-to-8 ratio. Okay, that does not work. Has to be lowest terms. That's why this is a 1-to-2. All right, so we're going to work on these some more in class. And if you have any, if you want to, you can go ahead and go work on some of those in the packet and try to do those. And that way we can go through those when we get to class.
Oxygen has recovered quickly from his little bump and can now be seen playing with barium. But they should be careful playing in that rocket, since oxygen is often used as ignition in engines. Curiously enough, barium is also used in fireworks, which produce a brilliant green hue. Don't be sad, oxygen.